Okay, let's dive right into this explainer and completely unlock the examiner's mind for your Cambridge Computer Science A-Level. Whether you're currently tackling the 9618 syllabus, or maybe you're building those crucial foundations in the 0417, 0478, 0983, 0984, or even the 2210 courses, you already know the harsh truth. Grasping the theory? Yeah, that's literally only half the battle. The real challenge is proving that knowledge under immense, ticking clock pressure. I want you to imagine a real past paper question sitting right in front of you. Let's say code 9713. The timer is counting down. On one side of the exam hall, we have a typical student. Let's call him Alex. Now, Alex completely overloads his answers with raw, unfiltered computer science facts, but he provides absolutely zero analysis. It's just a brain dump. On the other side, we have Sam. Sam rushes the paper. He's panicking about time, so he completely misses the specific requirements of the command words. Both Alex and Sam walk out of that exam hall feeling pretty confident, right? Yet weeks later, both end up staring at a barrage of red pen marks on the results sheet. Well, today, in this session, we are going to transform those red marks into green check marks. We are looking at the ultimate computer science success blueprint, and we're focusing on one of the most notoriously tricky topics out there: data integrity in database management systems.
Now, what's really interesting about this quote is that it sets the exact stakes for today's masterclass. A senior examiner is telling us, point blank, that data integrity in a DBMS isn't just some flashcard vocabulary word you memorized the night before. No way. It is a fundamental, structural concept that proves whether a candidate truly understands how databases maintain accuracy, consistency, and reliability over their entire lifecycle. When an examiner reads your paper, they aren't just scanning for a textbook definition of data integrity. They are looking for a demonstration of absolute mastery. They want to see that you can take this concept and apply it to complex, completely unfamiliar scenarios. That leap, from simply defining a term to applying it flawlessly in the wild, is precisely what separates a good B-grade student from an outstanding A-star student.
So here's our game plan. First, we'll get inside the examiner's mind. Second, we'll master the core principles. Third, we'll unpack the method mark strategy. Fourth, we're going to highlight the danger zones to avoid. And finally, we'll introduce a repeatable problem-solving framework.
Let's kick things off with Section 1. To beat the exam, you have to literally think like the person grading it.
This right here brilliantly illustrates exactly what separates that B from an A-star. Examiners demand analytical depth and reasoning that transfers to unfamiliar contexts. Think back to Alex, the student we talked about earlier. Alex relies entirely on superficial breadth. He memorizes his notes, drops technical keywords randomly into his paragraphs, and just crosses his fingers, hoping the examiner will piece his argument together for him. Honestly, that approach might scrape a pass, but it is never going to get you top marks. The Cambridge syllabus explicitly emphasizes that top-performing candidates exhibit a connected, conceptual understanding. This means if an exam question throws a completely novel business scenario at you, say a massive hospital database system that absolutely must ensure patient records aren't duplicated or corrupted, you can immediately draw a conceptual line right back to the core principles of data integrity. You don't just regurgitate facts, you show exactly how those facts govern the system's behavior.
These three distinct cognitive domains are the fundamental benchmarks your exam answers are measured against. It starts with knowledge and understanding, basically knowing what data integrity actually is. But you quickly have to level up to application, using that knowledge in whatever wild context the exam throws at you. Finally, you reach analytical depth and reasoning, where you evaluate why one database approach is objectively safer or more efficient than another. To hit all three of these domains consistently, you need a bulletproof strategy. Top students rely on the PEAL framework. That stands for point, evidence, explanation, link. You make your point about the database issue, you pull evidence from the specific scenario they gave you explain the technical concept, and finally, you link it right back to the command word in the question. And speaking of strategies, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, back to the strategy. Decoding the command word is your absolute rule number one. Are you evaluating? Are you describing? Your PEAL paragraph must match that command word perfectly.
Moving into our second section, let's look at how we apply systematic analysis. We're moving way beyond raw facts and diving into the actual mechanics of the exam.
I absolutely love this question because the principal examiner reports reveal a massive, totally avoidable trap that candidates fall into year after year. It is honestly heartbreaking to see students who clearly know their computer science concepts lose points just because of how they structure their extended responses. Remember Sam? Sam rushes. We see answers where the red pen marks just keep coming because the student, much like Sam, rushed right into the complex solution without setting up the groundwork. They start rambling about complex database architectures, normalization rules, and relational models without ever actually laying down the foundational definitions that the grading rubric strictly requires for those initial easy marks.
So the crucial takeaway is right here. Never, ever assume the examiner knows what you mean. Define your terms first. The principal examiner reports explicitly state that candidates consistently confuse key terminology. If you get an extended response question about data integrity in a Dbms, your very first sentence needs to define that term clearly. What is it? It's the overall accuracy, completeness, and consistency of data throughout its entire life cycle. By explicitly stating this before you even start your PL paragraphs, you instantly secure those baseline knowledge marks. From there, your analytical depth has a rock-solid foundation to stand on. We literally see students rewrite their answers live during our coaching sessions, making this one simple shift and watching their answers go from red marks to green check marks. It's the difference between a mid-tier ramble and a top-tier structured argument.
All right, let's dive into the core technical methodology where marks are actually awarded for your process, not just your final answer. This is where we systematically stack points. By actively following these 4 steps, you demonstrate the exact logical, structured reasoning that examiners are desperate to reward. When you face a beast of a database problem, algorithmic thinking is your lifeline. First, step-by-step decomposition. Break that massive problem down into bite-sized, manageable chunks. Second, appropriate data structure selection. Decide exactly how this data needs to be stored to maintain integrity. Third, efficient code implementation. Whether it's SQL or pseudocode, make it clean and direct. And fourth, rigorous testing, mentally running through your solution to ensure it doesn't break. The absolute beauty of this strategy is that even if your final answer isn't 100% perfect, you rack up method marks just for showing a logical process. The examiners want to see your brain working on the page. And look, if you want to master this, stop scrolling. Subscribe to our YouTube channel AC Exams at acexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to acexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Now, interpreting complex binary representations or massive data tables is notoriously hard for students, so mastering these 3 skills is your ultimate competitive edge. Let's do a quick mental workshop right now. Challenge 1, the data scan. Imagine I just flashed a complex data table on your screen and you have exactly 60 seconds. The clock is ticking. What do? You do not try to read every single cell. You scan to extract the core trend. You pull out the essential anomalies, perform any necessary calculations to spot validation errors, and then boom, you immediately draw an evidence-based conclusion about the integrity of that data. If you can perform this kind of rapid data scan accurately, you will absolutely breeze through the highest difficulty questions on the paper. This 4-part framework is your practical blueprint for showing your work. Let's move to challenge 2, find the flaw. Think about a flawed sample paragraph, maybe an answer where a student designs a brilliant solution to update a relational database, but they completely forget to mention how they would test the input data for anomalies. If you were looking at that answer, you should spot the missing step immediately. A top-tier student uses this framework to ensure no step is left behind. You design it, you implement it, you explicitly discuss testing, and you evaluate. Now, challenge 3, speed writing. In the exam, you'd have about 30 seconds to plan a perfect PL paragraph covering these steps. Keep this procedural framework locked in your mind, and you will systematically drain every available mark from the paper.
Let's move to our 4th section and explore the exact places where candidates are bleeding marks. These are the danger zones.
The crucial point here is that these are completely unforced errors. Checking your edge cases and tying your answer back to the prompt's context is absolutely mandatory. The principal examiners have practically been shouting this from the rooftops. First, overflow and edge cases. If a database field expects an integer up to a certain size, what happens if the data entered exceeds it? If you don't address that, you lose points. Second, failing to verify boundary conditions. You must show the examiner that you understand how a system behaves at its absolute breaking point. And third, this is the biggest one, giving generic answers. If the exam asks about a school's library database, your answer must talk about books, students, and due dates. If you just spit out a textbook definition of a relational database without linking it to the school, you score practically 0 for application. Don't be that candidate. If you ever find yourself blanking in the middle of the exam room, remember this memory hack. Use a visual story to recall complex database rules. Data integrity can feel super dry and abstract, right? So make it a movie in your head. Imagine a massive, heavily fortified bank vault. That vault is your Dbms. Now, imagine a strict security guard standing at the door. He's checking ID cards to make sure no duplicate people get in. That's entity integrity. Next, he's checking their badges to make sure anyone claiming to be a manager actually exists in the employee registry. That is referential integrity. Finally, he's checking their briefcases to make sure they only brought paper, not bricks. That's domain integrity. When you encode these theoretical rules into a vivid, weird little story, your brain will instantly pull them up when the pressure's on.
Finally, let's bring this whole entire masterclass together into a repeatable system. This is the final strategy you'll use on every single past paper.
This 5-step loop directly answers those brutal, higher-order assessment objectives that demand you evaluate alternatives. The minute you turn the page and see a 10-mark question staring you down, do not panic. Put it through the loop. First, identify exactly what constraints the examiner gave you. Second, break it into logical steps. Third, solve it systematically, using your Peel paragraphs. Fourth, pause and ask, is this reasonable? Does this database solution actually make sense for a real-world business? And fifth, make justified recommendations. That final step is the secret sauce. The hardest questions always ask you to compare approaches. You need to explicitly state why one method is superior for maintaining data integrity in that specific context.
And this brings us to the complete start-to-finish workflow. To guarantee you hit 100% of your mark potential, you need the 3 golden rules. Rule 1, command word decoding. Rule 2, Peel framework application. And Rule 3, the time management matrix. Understand that every mark on that paper represents a specific amount of time. Don't spend 10 minutes on a 2-mark definition, and don't rush a 12-mark evaluation. Execute your analysis with crystal clear working and present it exactly how the examiner requested.
Listen up, having the right resources and examiner insights is how you build an unfair advantage in the exam hall. Students who implement these exact computer science strategies see an average improvement of 2 whole grade boundaries. But, and this is a big but, only if they practice consistently with our weekly sessions. So here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
So, when you sit down to tackle your next past paper, I want you to ask yourself, are you going to be an Alex, relying on superficial facts, or are you going to prove the conceptual depth of an A-star computer scientist? Drop a comment below right now with your target grade for computer science and the biggest challenge you're facing. Our team responds to every single comment. Like and share this explainer with a study partner. AC Exams, your Cambridge success starts here. Keep analyzing, keep evaluating, and I'll see you in the next session.